Okay, so this is lesson 5.1 and it's B, it's the second one. We did multiplication with exponents in 5.1a. Now we're going to do scientific notation in 5.2 or 5.1b. Alright, so really all we're doing, all scientific notation, and I know you remember this, but it's probably long gone as far as being able to recall. I should say you remember it, you've done it before. Scientific notation is just another way to write a very large number or a very small number. Now in this section we're just going to deal with the very large numbers. So if we have a very large number like the one they have in the book, okay, so we just add a whole bunch of zeros here, and maybe that's in miles. Maybe that is how far a light year or how far light travels in a year. So how far is that? This is hundreds, 100,000, 100 million, 800 billion. So 5,880,000,000,000 miles. Okay, most of your calculators won't hold that much information. And you have a key on your calculator that might look like this. No, it won't look like that. I'm trying to think. I guess my calculator has a key that has this. It just depends on the calculator, I suppose. You'll have to kind of play around with your calculator and find out what it is. But anyway, the decimal of this number is actually right here, right? It's at the very end. Well, if we do not want to write a number that big, what we do is we take the very first digit and we write it down and we put the decimal after that. It's always after the first digit. And then we write the rest of the non-zero numbers. Okay? Then we make a time sign. We put a 10 here. And we count how far it is from the beginning of the digit where it was and where we moved it to. So we count how many places that is. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We moved it 12 places. So what we do is we put an exponent of 12 there. And all that exponent right there does is says this decimal is not in the right place. It's actually 12 places to the right. That's what that 12 means. We're just writing it this way because it's a shorter version of that. But if I want to know how big a number this is, that's how many decimal places I moved it in order to make this number smaller. So that's what that means. All scientific notation has first digit, decimal, a couple non-zero digits, times 10, and then this is how far we moved the zero from here, from its original place to the left. Okay, so let's try another one. 376, let's make it million. Okay, so we write first digit, decimal, next non-zero numbers, times 10, and then we count. We started here, and we move the decimal to here. So that is 1, 2, 3, 4, 5, 6, 7, 8 decimals. Okay? That's all there is to that. Now, let's say we want to take this and change it back to that. Okay, this is called scientific notation. This is called expanded form. So if we want to change it from expanded form to scientific notation, we do what we did here and here. If we have scientific notation and we want to move it back to expanded form, well, let's get a different number out here. 4.52 times 10 to the third power. Okay, so what that means, and this is what some people do to get started, they'll just write 4, 5, 2, and then just add a bunch of zeros here for a minute. And they'll say, okay, we started here. This number here says that we are 3 decimal places over in the wrong place. If we want to change this to what this number really looks like, we have to count 3 zeros to the right and put our decimal in there. So here's our decimal. We want to go 1, 2, 3. So we want our decimal point there. So it should not be here. It should actually be 3 places over. So it actually should be right there. And these zeros right here, we just added, I just stuck them on there just so you have zeros to count. So once you found where your decimal place was, you can get rid of all the other zeros after it. Those go away. They don't even actually exist. I just throw them in there so we didn't have to add a bunch. So that's what that is. So let's put, in fact, let's do one more just to make sure that we got this. Okay, so this is in scientific notation. We want to write this in expanded form. So there's my decimal. So I'm going to do the same thing. I'm just going to add a bunch of zeros here. It doesn't really matter how many you put on here. I mean, I can just add hundreds if I want. But okay, so let's go there. And this is just the way I do it. So I've got 3 there. So the decimal is there. This tells me in order to write it in expanded form, I have to move the decimal place over 7. So I'm here. 1, 2, 3, 4, 5, 6, 7. So that's where my decimal place goes. Okay? So my number is 3, 2, 5, 6, 1, 2, 3, 4 zeros. And then these can all go away. Anything to the right of the decimal, there's zeros, can go away. So there is this number expanded. Alright, so that's it for 5.1. Let's look at some of these practice problems, and hopefully you won't have any trouble with them, especially the exponent parts. Let's see, let's go all the way down to, well, let's do something like 38, because they always throw in some that look hard but really aren't. B to the r power times s. What do you know about exponents that are side by side like that with nothing in between? You multiply them. What's r times s? Well, r is not a number and s is not a number. They're 2 letters, so we just stick them together. Okay, so what if we have 0.5 ab squared? Well, we take 0.5, square it, a squared, and b squared. Whoops, parentheses out there. So 0.5 squared is 2.5, a squared is a squared, b squared is b squared, and you're done. Okay, the key thing is the squared goes on the number and each of the letters. Alright, so let's jump down to, well, let's look at 60. 3/4 a b to the 7th power cubed. Alright, again, we just separate everything out. Numbers cubed, letter cubed, letter cubed. So, 3/4, we cube each of those. Okay, 4 times 4 is 16, times 4 is 64. We cube that, and we cube that. And we're done. Okay. 65 to 70, you're writing each one in scientific notation, just like the ones we just practiced. If you have something like 68, negative 5,700, okay, this negative, it does not do anything. Take our number, put a decimal, make it times 10, and our decimal was there and we're moving it here, so how many decimal places did we go? 1, 2, 3, and we're done. And to go backwards, like on 74, okay, In scientific notation, that's telling me that's in the wrong place, that it needs to go 5 over to the left. And this is where I just kind of add a bunch of zeros. And I count over. My decimal was there. So 5 over to the left, to the right, is 1, 2, 3, 4, 5. So my decimal's right there. So I can get rid of those. So my number is 352,000. Okay, negative 352,000. So that negative doesn't really do anything. It's just kind of stays there. One of the parts on this that I didn't necessarily skip, but I kind of did, and that was just that little box on top of page 314. So I want to go back and at least remind you of a little geometry then. Volume of a rectangular solid. A rectangular solid is basically like an ice cube. Okay? Looks like that. And if we are looking for the volume, we're looking at, if we were to fill this thing full of water, how much it would hold. Okay, so the way you find volume is you take the length times the width times the height. Okay, so let's say that we have this rectangular solid that's three-dimensional, and let's say that's 5, this is 4, and the height is 3. So you just multiply all those together. So 5 times 3 is 15, 15 times 4 is 60. Okay? If your rectangular solid is a cube, so if it's a perfect cube like this, and this is 5, and this is 5, and this is 5, how many 5s do I have there? I have 3, so I could really write that as 5 cubed and get 125, because 5 times 5 is 25. 25 times 5 is 125. So you could do it like that, 5 cubed, and you've got that. So if you look at the problems on applying the concept 77 through 90, well actually 77 through 94, it has a whole bunch of stuff there that you're going to be using the exponents with. Okay, so like for example, 85. They're saying if you're 21 years old and you've been alive for more than 650 million seconds, write that number in scientific notation. Well, all you're going to do is take 650 million and turn it into scientific notation. You know, like I said before, just the first letter, or first number, decimal, the rest of the numbers times 10, and then count how many decimals you came from the end of the number to where it's between the 6 and the 5. So, should not give you any problems there, and that is completing 5.1. So this is 5.1b.